Hello all. In the previous video we have discussed about what is compiler, what is interpreter, some introduction about the compiler, applications of the compiler and the phases of compiler. So now we are going to see one numerical example for the phases of compiler and the grouping of phases. So now we already know about the phases of compiler. The phases of compiler are lexical analyzer. In the lexical analyzer, it is going to take the whole source code as an input and it is going to convert into token. The next one is semantic analyzer. The token is going to be the input for the syntax. Second one is syntax analyzer. The token is going to be the input for the syntax analyzer. That is going to convert it into the parse tree. And third phase is semantic analyzer. In semantic analyzer, it is going to take the input as a parse tree. It is going to convert into the annotated parse tree. And the fourth phase is intermediate code generator. From the annotated parse tree, it is going to write the intermediate code generator with the help of three address code. And the fifth phase is code optimization. If there is any possibility for reducing the line of code, that will be done under the code optimization phase. And the last phases of compiler is code generation, that is going to give the assembly code for the output of code optimization. So now we are going to see one example for the phases of compiler for a particular line, how the phases of compiler is going to convert into the machine code. So here I have taken the input as position colon equal to initial plus rate star 60. Our first phase is lexical analyzer. So lexical analyzer is nothing but the scanner. So what it is going to do is it is going to read the input, that is scan the input from the left to right. So while scanning, first it is going to scan the lexeme position. So for that lexeme position, first it has to identify what kind of token it is. We know the position is identifier. So the position will be stored under the token identifier. And the next it is going to read colon equal to. So the colon equal to is nothing but our assignment symbol. So this colon equal to will be stored under the token of symbols. And next it is going to read initial. So initial lexemes will be stored under the token of identifier. Next one is plus. Plus we know that as an operator that will be stored under the operator token. The next one is rate. Rate is also the identifier. Then star. Star is our operator and the 60. 60s are going to be the constant. So that is our number. So here in this line of code there is no keyword is available. So we didn't specify anything about the keyword here. So from this line of code it is going to classify in the token as identifier, operator, symbol and constant. It is not using any keyword here. So now the token is going to be the input for the next phases of compiler, that is our syntax analyzer. So in syntax analyzer what it is going to do is it is going to convert our source of code in the form of parse tree. So in the parse tree, always the parent node or the root node, it is going to be either the symbol or the operator, and remaining operands or identifier or the constant, that and all it is going to be the leaf node. That all the interior node and the root node, always it is going to be either the symbol or the operator. So now the parse tree is constructed for position colon equal to initial plus rate star 60. So here position is an identifier, colon and equal to is an assignment statement, and initial is an identifier. So the totally we are going to say it as initial rate star 60 as an expression. So under that expression our initial is an identifier and here the plus is the operator, and rate star 60 is an another expression. So rate is an identifier and star is an another operator and 60 is a constant value. So now the syntax analyzer have converted the given tokens in the form of syntax tree for the given example. Now the third phase of compiler is our semantic analysis. Semantic analysis, it is going to convert the parse tree into the abstract syntax tree as well as annotated abstract syntax tree. So abstract syntax tree is nothing but just it is going to write the parse tree And annotated syntax tree, what it is going to do is it is going to convert all the integer into the real values. That position equal to plus after doing addition it is going to give the real value. After doing multiplication, here it is going to give the real value. So real star 60. So here star is also it is going to take in it as a integer to float, that is it is a real value. So that will be done. The conversion of integer to float will be done under the semantic phase. That is our third phase of compiler. So this annotated abstract syntax tree is going to be the input for our fourth phase, that is intermediate code generation. So intermediate code generation is going to write the source code, write the code with the three by using the three address code. So position colon equal to initial plus rate star 60. So first this star 60, that integer value, it is according to our annotated syntax tree. First it has to convert that integer into real. So it is converting this 10 into real. So that is integer to real, that will be assigned in the temporary variable temp1. Then next it is going to do the multiplication operation, that is rate star 60. This rate star 60 according to our syntax tree, that is our pass tree, it is an id3. So id3 into temp1 will be stored under the temp2 variable. This rate star 10 value is stored under the temp2 variable, and here our initial is id2. So id2 plus this temp2 will be stored under the temp3, and the whole temp3 will be stored under the position. Here our position is going to be the id1. So now the code is constructed, that intermediate code generation is constructed for position colon equal to initial plus rate star 60 from the annotated pass tree. So here the position is id1, initial is id2, and rate is id3. So based on that identifier name, it has constructed the intermediate code generation. Now the next phase is code optimization. This output is going to be the input for the code optimization, and it is going to check whether there is any possibility to reduce the line of code. So how we can reduce the line of code? So directly, instead of saving this into real 10 into the temporary variable 1, directly it can write the integer to real. So temp2 colon equal to id3 star into real 10. So our id3 is nothing but rate, and that will be stored under the temporary variable temp2. So now id2 is our initial value. So this id2 plus temp2, we are going to add it, and we are going to store that in temp3. The final value is temp3, that will be stored under the identifier 1, that is our position. So this is our code optimization. So for this, now we have to write the code generation has to generate the code. It is going to generate the code generation has to generate the assembly code. So this is the final assembly code generated by the phases of compiler for a single line position colon equal to initial plus right star 60. So here what it is going to do is it is going to multiply id3 star 60. So actually here I have written it as an id3, but actual assembly code, it will be using the general purpose register. Just for our understanding, I have written it as an id3, but our machine code will be in the form of mul r1 comma 10 or mul r2 comma 10. Mostly it will be using the general purpose registers. So mul id3 comma 10 is our identifier 3 is rate. So it is going to do the multiplication of id3 and 10, and it is going to store the result in id3. So here id3 is nothing but our general purpose register r3. And now add id3 comma id2. So add id3 is rate star 10, and add id2 is initial. So it is going to add both the values of id3 and id2, and it is going to store the result in id3. So here we are going to assume that id3 as a general purpose register. So now this id3 is going to hold the value of initial plus rate star 60, and we have to move the result to id1. So to move the result, first it is going to do the load, but load and store instruction is going to it will accept the one address instruction. So load id3, what it is going to do is it is going to load the id3 value into the accumulator, and store id1 is from the accumulator, it is going to store the value to id1. So now ID1 position is going to hold the value of initial plus rate star into integer to real of 60, the real value of 60. This will be stored under the position. So that is the main process in the phases of compiler. So now the next topic is grouping of phases of compiler. The phases of compiler can be grouped into two phases. One is analysis phase and another one is synthesis phase. The first four phases of compiler, that is our lexical analyzer, syntax analyzer, semantic analyzer, and the intermediate code generator will come under the analysis phase, and in synthesis phase the code optimization and the target code generator will come under the synthesis phase. So in this video we have covered the example of the phases of compiler and the grouping of the phases of the compiler. In the next example, what we are going to see is how we are going to convert the regular expression with the help of compiler techniques into how we are going to construct into the DFA. That is our next video that we will be seeing in our next video. Thank you.